Hi, we are engineering brothers. In our previous class, we have considered the pole at our origin over there, and how do I consider that one in terms of stability that I have already described in a previous part of our considered point. I do require to refresh over here once again. First of all, the transfer function will be Cs by Rs, which is Gs, and our ultimate objective is to consider the whether the system is stable or not, or which one is the stable considered part over here. Here, if you do apply the inverse Laplace of this Gs, we are having our Gt, and our ultimate focus is to analyze the system, which is Gt, and whether that one is stable or not. To have that one, we are having this ratio as our transfer function over here, and we have applied the impulse response on that given considered part over here. Now if you just do apply the much needed impulse response in our given equation, the Rs will be 0, and if you just put that Rs is equal to 1 in our given equation, we are having this one. This is our given equation. And as for our considered part, we have considered as per S plane that the pole is placed at the origin over here. So quite naturally, we have considered that our much needed Gs will be 1 by S, and if you just do apply the inverse Laplace on that given equation, we are having Ct is equal to 1. And we have considered that in our given form of our considered part over here, and we have already told you that as the value is constant throughout the operation, that is not increasing or decreasing in any way over there. If you just do consider the t tends to infinity over there, the value throughout our operation will be constant for that one. Because of that one, we can say that the system is marginally stable. Now let us just go to the next part, which is our next diagram will be considered over here, which is only the two nodes. Okay, the much needed considered the two poles that are placed in our given origin over there, that will be our considered part over here. Now we should start over here once again. First of all, the Cs is equal to GSRS, or in our another considered part, we can say that the Cs by Rs, which is actually Gs. Now once again, if you just do apply the much needed impulse response in our given equation, the equation do have from this one, which is Cs is equal to our Gs. Why? After we have considered the input as our impulse response, the Rs will be 1, and quite naturally Cs will be Gs. Now for our second part, we can say that for our given system, the poles, or quite naturally the two poles, are placed at the 0 point of our S plane over here. That is why we can say that 1 divided by S square. Now once again, if you just do apply the inverse Laplace on that given equation, we can get back to the much needed time domain analysis over there, which is Ct, and ultimately the equation will be T. Okay, and we have plotted that equation over here, and if you just do increase that time, it is been increasing in that way. And once again, I can say that if you just do like to comment on that stability on that given considered part, we can say that the system is marginally stable over here. Why? Because as the much needed two poles are placed at the origin of our S plane, and because of that one, we have considered Gs is equal to 1 by S square. And if you just do apply the inverse Laplace on that given equation we are having Ct is equal to T, and we have drawn that in our given waveform over here. This is quite naturally the considered part for our stability over here. Before you just do require to understand the totality of our stability, you should understand this part over here. So in our previous part, we have considered the poles, only one single pole that is placed at the origin of our S-plane. And in our next step, we have considered two poles, two simple poles that are placed at the origin of our given system over here. And for these two type of considered part, we can say that both that one as our marginal stability consideration. Why? Because the pole is placed in between our stable and unstable part over here. And how do we define the stability considered part according to our S-plane? If the considered pole are placed at the left hand side of our given considered region, we can say that, or we can comment that the system is stable. And if that pole is placed at the right hand side of our S-plane, we can say that the system is unstable. But in between our stable and unstable consideration, if the pole is placed at the middle part of our considered axis, or at the middle part of our j omega axis, that is not present in our left hand side, and that is also not been present at our right hand side as well. But in between our two extreme points, or in between our stable and unstable points, the pole is placed in between our two considered part over here. That is why we can say that for these two type of considered part, the system is marginally stable. Okay, and I have already considered the pole that is placed at the origin and the two poles that is placed at the origin as well. In our next part, we should focus on our many other considered parts, or whether the change of the pole that actually do give us what seems to be the time domain or the output response for that given considered part over here, then we can comment that as per our stability analysis over here. That one is very, very important. I hope you have totally understood up to this one. If you still have any doubts, please let us know in the comment section. For better understanding, do like, do share our videos, keep following our channel. That's it. Thank you and goodbye.
If you like my video, so what are you waiting for? Please do subscribe my channel, hit the bell icon for more updates, and stay tuned to the channel. Thank you and goodbye.